Oh, we never added Ben's poll for drainage. We just want to ask that.
Yeah, we can have it in the chat.
Welcome to OpenRoads Designer Roundtable. We're going to start off here with a quick poll. I'm Patrick Stone. I work in the technical support branch. I'm going to give you a couple minutes to complete the first poll. Now, we'll have one additional poll at the end of the presentations before the roundtable discussion. Please post your questions in the chat room or in the chat dialogue here on the side, and we'll discuss that during the roundtable discussion. And we'll give you just a minute or two more to complete this poll. And those of you that are just getting in here, please post all your questions in the chat, and we'll monitor those and pick those up at the end. It looks like the polls are tapering off here. Let's give it another 15, 20 seconds. Okay, well, the polls are in. The results were about 58% of you know you do not currently have an OpenRoad designer project active. So with that, I'm going to turn it over to Chris James, and he'll start us off. Good, Chris?
Yes, sir. Can you hear me?
Yes.
Okay. Thanks, Patrick. As Patrick said, my name is Chris James, and I'm the Design Section Supervisor for the Pikeville District Office. I just want to share some of our experiences that we've had with OpenRoads. Some of the folks in our office have been using OpenRoads for a few months, and first thing I want to make sure that everybody is aware of, it's definitely different. If you've had a chance to use the software, you know what I'm talking about. Many things are quite a bit different from what we're used to. But there's some things that are the same. So hopefully we can hit on both of those types of topics today and hopefully give you some information that's beneficial and you can take back to the office with you. One of the things I wanted to point out first was going to the Kentucky Transportation website and looking at the CAD standards. There is some really beneficial information there if you want to get started using OpenRoads. I remember last fall when we first started using OpenRoads, we didn't really rely too much on the CAD standard policy, and we were essentially trying to figure out some things on our own. And once we got the policy, a lot of things started to make a lot more sense, and it gives you a lot better framework for working with your files, knowing what they should be named, and also coordinating and collaborating with other folks. So like I said, there's some things that are the same and some things that are different. One of the things that's really the same is that KYTC's deliverable is still the PDF contract document. So that should be something that we're all familiar with. We've been doing that for a number of years now. So that is still the actual deliverable for your project. The thing that's different, though, is that now one of the deliverables is the electronic engineering data. You can see here in this screenshot that the new structure that you would be delivering on a project has under contract plans and proposal a directory called electronic engineering data. Now that directory is a set structure, and I'll show in a second how many different subdirectories it has, but that will always be submitted when you have an OpenRoads project. The electronic engineering data directory has subdirectories that are specifically suited for OpenRoads project design. Here on the left, you can see a screenshot of a project that Terry Stallard is working on in District 12. And it shows an electronic engineering data directory that has a number of subdirectories. And it goes anywhere from control elements to geometry to super elevation, terrain, and so forth. A lot of those terms are very similar to what we're familiar with. However, there's a few of them that's different. What I like about this structure is that it reminds you what the different files are meant to be used for. It also reminds you what types of files that OpenRoads needs. Just to point out, you'll see that there's some directories that are not as part of this subdirectory, but the key is that these are the ones that OpenRoads is trying to use. The other thing I wanted to point out was that this structure can be used throughout the design of the project. So it's not just about the deliverable. It can also be used from the very beginning. And again, that's one of the things that really stood out to me is even at the first stage of your preliminary design, by using this structure, it really helps to maintain your understanding of where your files are. And if you quickly need to access something like a geometry file or a super elevation file, you know right where it's at. If you've used OpenRoads, you know that it has numerous DGN files that you create throughout the design process. So this helps with that structure of organizing all of your information. The electronic engineering data files are highly interdependent. So like we just showed in the previous screen, you see a lot of different types of subdirectories. These files work together, whether it be a terrain being used for a geometry file or a corridor using a geometry or so forth. So having those names and structures set really helps you with the overall workings of the program. This is a screenshot that Terry Stallard has created for his Garrett Ramp project in Floyd County. And you can see how he has multiple DGNs for geometry. And if you're familiar with SS2, probably like most of us are, I would imagine, in the old days, an ALG file contained all of your geometry. Now, your geometry is in a DGN file. It's recommended to make sure to have those geometries separated, and it really helps with the overall organization. The file names is also important because you can quickly identify what the file type is and what it relates to. Speaking of the fact that we have so many DGN files through OpenRoads, you also will see that there's a term called container files. Container files are something that helps to bring together a range of different files into one particular topic. In this screenshot from the CAD standards, you can see that there were multiple corridors on a particular project, but then you have a corridor container file. What I like about that is instead of having to reference bukus of different individual files, you can reference one file for corridors, and that's all that you would need. It would give you everything that you need for the corridors for that particular project. So like I said, we've been working with OpenRoads for a while now, and this is an example of a project that Justin Reichenbach and I have worked on up in Kenton County in District 6 for 6-8916 in Kenton County. This is called the Houston Road Extension Project, and this is just a simple screenshot of a 2D view using the corridor file. And a lot of this probably looks very similar to what you're familiar with. You see edge of pavements, you see entrances, intersections, approach roads, and so forth. So the basics of what you're trying to accomplish are the same. How you get there, that's what's different. You can see there's different lines and purple dashed lines and maybe a corridor line that sticks to the top of your corridor. So the basics of what you're trying to accomplish haven't changed. How you get to that point, that's really the big difference. This is the same project and roughly the same area, and this shows the 3D view from the corridor modeling. This is one of our alternates that we took to preliminary line and grade. So you can see there's still plenty of things to work out with this. This is not a finished model by any means, but you can see how things have come together, whether it be entrances, medians, it has the materials for grass and pavement and so on. So that's one thing I like about OpenRoads is it allows you to see that three-dimensional view as you're creating and designing your project. This project is, like I said, we've just gotten to the preliminary line and grade stage, so we're still early in the design process, and we're still learning with OpenRoads by all means. If Justin was here, he could tell us definitely we still have a lot to learn, and that's the good thing about having a project to work with is you begin to see all the things you need to learn. One of the big things you have to learn is the terminology that is being used in OpenRoads, and I'll hand that over to Erika and let her discuss that topic.
Thanks, Chris. to more talk about what Chris is referencing to, the interdependency of the files, he's talking about where the files are referenced into each other. And he's talking about the different types of models that are in the files. And there's three main models that are in the files. That's the design model, that's the drawing model, and the sheet model. In the design model, you have your typical 2D model and the 3D model, and that's where all the design is done. And that's what you're typically used to in SS2 and SS4. This is where all the container files are referenced to, and this is no different than what you're used to in SS2 and SS4. Now what we have is the drawing model. This is what the design model is referenced into. This is what the name boundary creates. And in the drawing model, this is where you want to do most of your annotations for your sheets. And the drawing and the design model are all 1-to-1 scale and geospatially located. Now, the sheet model is not geospatially located, and it is not 1-to-1 scale. It is an actual 36 by 22 size. So it is preferred not to do much drawing in it. You can do some annotation in it for like the title block and other things like that. Alan and Aaron will discuss that more in the production side. But the drawing model will be referenced into the sheet model and shrunk down to the actual sheet size. And here you can see the different types of models and what the icons look like. And these are not to be confused with the different types of model within OpenRoads itself. Used to, you had the different types of products. You had you had actual inroads, you had inroads storm sanitary, you had inroads rail, and all that stuff to design the actual drainage, roadway modeler, all that stuff. Now all that's combined. In the top left, you will actually have, let's see if I can move this. You'll actually have a tab here to change the different types of models. If you want to switch to the drainage model to actually do drainage work, this is where you'll do that. And that's where all your drainage commands will be. And instead of inroad survey, you'll switch to the survey tab. And to talk more about survey, I'll hand that off to Ben Shinabery.
Thanks, Erika. So our model is going to begin at the point of survey. We're gathering information and compiling a 3D survey. And in the past, using inroads, we were modeling terrain features and bridge features, and then combining all of that with different DTM surfaces. We are still getting to learn OpenRoads, and what I'm finding is that all of those same survey codes and features and layers are in OpenRoads, but they may be in different spots. So learning the integration of OpenRoads in creating the base map is what is new. There are a few new rendering views and a new feature called zones that helps isolate survey information that can be used in OpenRoads and help with the interactive qualities of OpenRoads. But now what we also have are the inclusion of creating solid features or reality meshes so that the integration of high definition existing features can be viewed in other views within the 3D design space. So in the past, OpenRoads didn't have a way of showing solids within cross sections and profiles, but now anything that is in the 3D design model, including solid features, surface features that are not a part of a DTM, reality mesh that's captured either with aerial photogrammetry or laser scanning will show up in your 3D model views. So you can use them in cross sections and profiles. And Alan will show us a little bit of that here in a bit. But all of this helps to render the existing conditions in a very understandable way. So on this image, you can see instead of just rendering contour lines, we can show the 3D face with shading. We can show it in a new elevation view that shows the elevations of low to high, so it's easily determined what the high points are in the terrain model and what the low points are in the terrain model. And all of this happens in OpenRoads. So combining information to create the most realistic survey feature within OpenRoads is what we're striving for, including the ground surface, including vertical infrastructure like bridges and beams, drainage features, and Alan will go into the interactive drainage modeling, and utilities. And all of this, because this is an open discussion, hopefully in the chat room, we can have some questions come in that include what would you like to see in a 3D survey DGN for drainage features or for utilities. Do you like separating out the different quality levels for the utilities, and then how all of that will interact with your design? So to show some of these features, I'm going to hand it off to Alan. He'll show you how the interaction of these elements with a quick video that shows the intelligent design based on the base map of the existing survey. So I'll hand it over to you, Alan.
Thanks, Ben. All right. So I am going to speak very fast, and this video will move very fast, but hopefully you guys will see the recording of this video if you guys need to refer back to it. But I think the important part of what we're going to be covering here is the ability to do some of these things and not necessarily how to do some of these things. So let me load the video. So it seems like the video is not playing at all.
Should be going, Alan.
Can you start it? I think we've been having video issues.
It's running on my end.
Oh, I don't see anything. Well, excuse me. Sorry about this. Hold on one sec. Okay, so I can't see it in the host view, but I can see it if I open up the other view. Well, no, I can't. Patrick, do you see the video playing still?
You want me to try to kick it off for you, Alan?
Can you? Let me get out and go back in really quick. Sorry about that.
That's okay. Alan's, it was running. Let's see. Yeah. Chris James, you want to tell a joke while Alan's out, or I know Moses is full of it. He could come on here and tell us a little something.
I mean, I just hope my wrinkly sheet didn't like distract everyone.
I liked Alan's lit up crown molding.
Yeah, I know.
And his hair. Oh my God.
Yeah, you gotta like the hair.
Yeah.
You back with us yet, Alan?
Looks like he's back, but not.
Well, he's got it on there. Just you want me to launch it?
Hey, can you guys hear me?
Yes.
Oh, okay, good. All right. No, I see everything now. We're good. Okay, so sorry about that technical difficulty. Okay, seems to be going back and forth. All right, let's just quickly talk about this. But so we have a great survey from Ben. We have the beams modeled with solids, and what I'm doing here really quick is just creating our base geometry of an underpass. And we see everything in the 3D view. And what's unique about this is that it's a tapered beams, and typically we may not always deal with this all the time. But for this particular case, I want to design the bridge and make sure I have the appropriate clearances underneath. Now, all of these techniques could have been done with OpenRoads, but I'm going to show you the new way or how it is being done in OpenRoads or in OpenRoads. And so what I'm doing is I'm taking our standard template and I'm creating a vertical clearance box of 16.5 feet or 18.5 feet or 50 feet. But what I'm going to be doing is modeling this shape, and then I'm going to be visually inspecting how that shape interacts with those beams. Traditionally, you'd have to check your clearances by running through Excel and going through your PGL and finding out your slopes and going to the bridge surface above it and grabbing your points on your DTM and making sure you have enough clearance by subtracting your deck and your assumed bridge depth. Or you can run profiles along your important pieces. And so a lot of those things are very time consuming, especially in the design process, especially if I'm just a roadway designer trying to make sure I hit my clearances and I need to move on to like 10 other bridges or something. But in this case here, if we use the modeling techniques, what I'm doing is rotating in the 3D view, and I'm looking for daylight. I'm trying to see if I could see a clear distinction between the top of my vertical clearance box and the bottom of my beam. Now this is great because in this one particular case, I know that I hit clearance, so I don't have to do anything else, or I may want to increase it. I might want to change the view so I can see things a little bit better. I might want to turn some levels on and off. But this is kind of one of those really nice scenarios where we have a unique beam and I want to make sure I hit it at I hit clearances at my pinch points that I may not always see very easily in my traditional 2D view. Now, let's say in the middle of the design process, we now have to meet 18.5 clearance for whatever reason. And now my 16.5 clearance, I was perfect, I was fine. I was matching existing ground, but now 18.5 clearance, I might be a little bit more worried about it. I may not hit 18.5 clearance. So here, can I see clear daylight? No, I might want to zoom in a little bit. And so here, if we zoom in a lot further, I can see that my shape is going right through one of the beams. Again, nothing new here. We could have done this with inroads. We could have also done the ISO patch in inroads. In this version, it's called a Delta Terrain Model. And also the previous version and in this version, we have clash detection. But in this case, clash detection is moved under the drainage and utilities. It's specifically made for detecting if there are utility conflicts. So when I check a feature definition against a level or two feature definitions, I have these spheres. And these are the points of which my components or my model or any of these levels are actually making a hard conflict with these beams. So if I'm a reviewer, I can do this, run this for this whole project, and I can find all the clashes. As a roadway designer, in inroads, I would have to change a profile and move down and check and do all these manual efforts to process. But as you can see in OpenRoads with the automatic processing, it's a lot simpler to go in and change the profile in one view and have it automatically update in the next view. And I can say with reasonable confidence that I am hitting my clearances. Now, if I send this back to a reviewer, they can go in, just open up their file. Their references should be automatically updated, but their spheres are still there. I'm going to delete all the conflicts and reprocess it. If I don't see anything, then it's great. Then I clear everything. So that's one of the major benefits of modeling your solids and combining that with modeling techniques. Now let's take a look at how we would what would be new. And so let's take this same bridge scenario, and I want to create plan and profile sheets from it. Traditionally, if I wanted to model or draft the profile, I would have to draft every single piece of that bridge in the right elevation and do a bunch of calculations. In this case here, we have a tool that can, in the profile view, in every profile view, that can pull the information from the 3D model and bring it into the profile without us ever having to draft anything. So if this is already given to us by Ben, and we have any utilities, or if I have another model, I don't have to do any additional drafting. I can just pull the profile and I can pull everything in the 3D view right in my profile. Now, that's great if I'm doing everything in design and I want to hit everything in that 2D view, but when I want to create sheets, it's just pulling that same profile view into the sheets. So this is an example of how we would create profile sheets in the new in OpenRoads Designer. So this case here, I'm going to choose my appropriate drawing seed. I'm going to choose my alignment, and I'm going to place the name boundary. I'm going to make sure I don't hit the create drawing first, just because I want to move my profile drawing somewhere else. I can change this any which way. I can change the clearances. I can change the elevation, but I like doing it this way. I like placing the name boundary, going to the adjust profile name boundary tool, and then moving it up. And then I'm going to go in and create the sheet. So my name boundary is going to go to my name profile, my name boundary, and create profile drawing. So if the workspace is set up and you're using the right seed, your sheet will come in, the annotation will come in. If I have specific things I want to annotate, and we'll talk about that a little bit later, we'll dive a little bit deeper into annotation in OpenRoads Designer. But if we have some of these feature definitions that are set up appropriately, I could see elevations, I can see slopes, I can see points, I can see names. But that's just one of the key features of what OpenRoads Designer, the differences, one of the key differences. Now, we'll touch a little bit about drainage. So KYTC is still working on the development of their drainage workspace. But in this case here, I'm just going to quickly show you how drainage geometric modeling will work. And so here I am placing a place node, and I'm going to place some outfalls. This is the same exact example. Choosing the existing ground, I have the ability for me to place it in 2D and choose the rotation, very similar to how I would use it in inroads. But one of the key points was it would ask me to click on the terrain model or the elevation reference point, and it will automatically place that elevation in 3D. So I click it in 2D, I place it in 2D, and it draws it in 3D automatically. But not only do I have to choose an existing terrain model, I can choose any 3D feature. So this could be my proposed design. So in this case here, I'm placing an inlet, and I chose my proposed design, and it places the elevation automatically. So when you zoom in and you draw in, I do want to highlight that we want to get away from having to delete and redraw our design. And so here, if I happen to choose the wrong rotation, I can just click on it and click and drag. If I happen to choose the wrong location, I don't have to delete it and redraw. I can just click on the node and move it. And if the elevation is not, if I chose the wrong elevation or it's stuck at an elevation, there's many different ways I can change that. I can choose a new reference surface. So here you have an elevation reference, and I'm going to choose the asphalt surface. Or I can choose another line, or I can manually change the elevation of my invert or the top. So there's different ways you can do this through the properties. You can do this through the hydraulic properties. And then I'm going to place a manhole. So this is kind of new. Before, I think there was just a culvert. And in this case here, we're going to redesign the culvert, and we're going to add a new part of that network to it. Again, trying to not delete redraw. If I happen to place the wrong manhole, so this I chose a T, I can just go to the properties and choose a new feature definition, and it will update the 3D view of it, the solid. I just want a cylinder, so I'm just going to choose a cylinder. And then the next step is I'm just going to connect the dots. So I'm going to choose the conduit, I'm going to choose the right size, the right feature definition, and as you can see, my interface is on the 2D. It's on the left side, and it's automatically placing a profile for me. And that's just your first step. We're going to move. We're going to move them later. So here I have my two inlets from the street, my 2 curb inlets, and I connected that to the manhole, which is connected to the culvert. And I want to take a look at this one run. All right, so I have my pipe here. I did the same 3D view that I've done, the 3D cut that I did in the bridge example, because I want to see the utilities. I have some existing utilities in there I want to make sure I clear. So I'm just going in and I'm manually just eyeballing the change of the inlet. And when it brings that in, it brings in whatever that inlet looks like in 3 dimensions. So if you have a really good looking inlet that's modeled surface-wise perfect, you'll see exactly what that's going to look like in reality in that profile view. There's no additional drafting. Here, I'm draining in the wrong direction, so I'm just going to increase the length. And when I increase that height, the height of that manhole, my 3D view automatically updates with it. So it's always trying to update whatever change I make in 2D, my design intent is always going to be there. There's no additional processing. In order to get my outfall, or to get a big profile, I'm going to create a hydraulic run to outfall, and that kind of creates a stringed alignment at all the different locations that lead to that outfall. So this is what it looks like. Now, what I can do then, similar to how I worked on the bridge, I'm going to create a profile sheet for this pipe. So it's pretty much the same exact tools. I'm going to create a name boundary. I have that profile view of that profile run open. If I want to show everything, I'm going to hit the 3D cut. I can always turn off some levels in the 3D view and refresh the screen. I'm going to place my name boundary. I happen to choose a negative value for my start location because I wanted, some blank space before and blank space afterwards. And then I'm going to create the sheet. Now, this is just the geometric part. The hydraulic analysis and a lot of the design part is also built into this. There's hydraulic properties that are tied to each feature definition and how it gets all calculated. I'm not a drainage engineer, but I do know that that's how it's being worked, that's how it's being done, that's how the design is being analyzed. You design your geometrics and modeling, and then you analyze it through many of the Hasted product tools. Here we have different views. We have our analysis profile that some people are used to. We also have our engineering profile. And it also comes with some annotation and some features. Again, same thing. If we have the annotation set up with our feature definitions in the first method of creating our sheets, we'll get our annotation that we want. And we can place this drawing in here, kind of similar to how I think one of the inroads versions does it to a DXF or DWG or DGN. So we're going to quickly move over to how annotation works with Aaron. So I'll turn it over to Aaron.
Thanks, Alan. I'm going to get the slides back up here for us. All right, perfect. So I'm Aaron McCown. Most of y'all probably either dealt with me via email or I've helped you out some way with the CAD support, but I work in the CAD section under Kevin Martin. Most of my main work has been in production, mainly sheet annotation and just annotations in general with cross sections and sheet production. So what I'm going to talk about today kind of leads into what Alan was talking about, which was 3D models and annotation. So what I'm going to talk about is how to get your survey and your existing right-of-way into your cross sections and get it to annotate them automatically. We're going to go through this really quick. It's going to be kind of a broad level. So you get your survey file from your surveyor. It's going to come in as a 3D file. We call that a base map. Once you get your base map, you're going to create a new file called a control elements file. And in this file, you're going to reference in your survey, merge the master, so you can just get the graphics. And once you get the graphics, you then treat those graphics as an alignment. Because the only way currently to make your utilities work inside of a file in the cross section is to treat them like an alignment and to get them to work. So you have to have a horizontal, vertical, and a profile for each one. You want to make sure the feature definition is set correctly as well, because the feature definition is what controls. Can y'all hear me? Everybody good?
Yeah, I can hear you. Go ahead.
Yep.
Okay, sorry, Ben.
I can hear you.
Okay, yeah, Ben said he couldn't hear me. So warning about that. Oh yeah, I have camera too. Forgot about that.
And a tie. Holy crap.
Yeah. Got my tie on. So once you set the feature definition, that is what controls what you see inside the cross section, the cell. It'll pull that cell for you. And if you're using something like your existing right of way, you want to drape that like you did in Instance 2. And the tool for that is now called Quick Profile from Surface. It'll just drape your alignment across the surface for you. And once you get your, thanks, Charlie. And once you get your corridor working and you bring your corridor in, you reference your control elements, you then can actually see your line styles that you create in your control elements file show up in your 3D model. In this example here, you can see I have my corridor, my 3D model for my road. On the left and right hand side, you can see the control of access line. There's a water main, there's a sanitary sewer crossing it. And from here, you can actually see where those are in a 3D space. When you go to create your cross sections, you create your boundaries, and in those boundaries, you'll actually see these lines go through it in space, and that way you can actually make sure that you are crossing through those boundaries. If not, they will not show up on the cross section. And so for our last slide here, I have a cross section that I just took a picture of here real quick. And it's annotating all the elements crossing the boundary, like I said before. And these are delivered in what's called annotation groups. And what these annotation groups are is they look for a certain feature definition that crosses through the boundary. And once it sees that, it then goes and pulls the cell and places it accordingly. But with the utilities, we have some different cells that deal with quality levels. I'm going to let Kevin Martin talk about those.
Yeah, so first off, Aaron, are you wearing pants? That's the most important thing.
That's none of your business what you really want to know.
Not really. I figured Charlie wanted to know. No, yeah, just tying into what Aaron's talking about on annotations and what Ben was talking about earlier about picking up subsurface objects. Everything needs to be in the 3D model. So we've decided to go the route of quality levels for our utilities. So we've created feature definitions for the different quality levels. So you'll have A, B, and then C and D, because the way we display those in annotations, there's no difference between C and D. So as long as you pick the right one for that particular object, you should be able to get your annotations. If not, you might want to check that and make sure you've got the right standards loaded, because these are, I forget which version, but I think it came out earlier this year. I think, yeah, it's during the quarantine. So one of these recent updates will have those quality levels, and we're probably going to have to add some more later as well. Excuse me. Just wanted to also point out dynamics work a little different. So if you're bringing up utilities in your dynamic sections, they will not display the quality level A hull elevations. So, and that's by design, it just won't do it. So there's a different cell for that. So if you're not getting elevations in dynamics, that's actually correct. And then we've had some drainage questions. So real quick, I wanted to touch on that just while it's on my mind, but we got asked about drainage cells. We are working on those. Kentucky has never had 3D drainage cells before, and it was going to take us about a year to build the library. But thanks to Alan and his amazing hair, he has automated a lot of that for us. So we're probably looking at a few weeks. We just don't have the time and resources to really dedicate to it right now. But we've got, I think it's the StormCAD stuff has been imported. We've got pieces and parts of it set up. So we are working towards that. Hopefully by the end of the year, we'll be able to get that stuff set up and running. And then somebody asked a question. Yeah, I think Will asked the question about how to do it today. Unfortunately, drainage today is just like it always has been. It's a 2D process. Analyze it ever how you can, and you're just going to have to draw the stuff into your plan profile cross-section views until we can get this other stuff set up. So who's next?
Yep, that's me. Sorry, I'm changing over. Hey guys.
Hey.
Okay, all right. So thanks, Kevin. So tying into how some of that stuff works, and we're kind of short on time, so we might go a little bit faster. I might click around a little bit, But I do want to really stress the importance of making sure you have your feature definitions set. So what's kind of new in OpenRoads versus inRoads SS2 is that feature definitions really dictate pretty much everything. And if you want to take advantage of some of these automated tools to do some drafting or to do some of the other design elements, you need to make sure you have your feature definitions set up appropriately. So here's a little message. I really want to make sure you guys understand if you're going to be upgrading your templates, using your SS2 templates, you need to upgrade them to ORD in the right way, and we'll show you in a bit. So feature definitions work by storing symbologies, which work by storing annotation groups, and those annotation groups store annotation definitions. So kind of building on what Aaron had said before, it kind of goes this way. So you choose your feature definition of whatever design element you have, and that governs how it acts and how it performs, and symbologies govern how it looks. And annotation groups govern a whole set of how it annotates, and then your definitions are just each individual piece of that. So within your annotation group, if I go into annotation group and look at cross sections and right click and hit manage or hit varies and hit the 3 dots, we're going to take a look really quick into how some of the annotation works. So you have this excess point annotation for your center line, but we have this location here. So it's kind of highlighted in red. And what you'll be able to do in some cases, you can go in there and dictate that if your template point is labeled CL, ALG, or ALGCL or LTGP or RTGP, if it has a point name, then I want to label it with this text favorite. So this text favorite will be like the point name or the elevation or the offset or both. And so you can select points from a template, and this is all set up in the workspace. And also by virtue of how the software works, you can custom make it into your own DGN, but that kind of is an inefficient way of doing it. But you can get as crazy as you want it to be. So for instance, we want to label the lengths. And so you see the filter here says 0.2 minus 0.1 elevation, and I want this to be on top, and I don't want it to be underneath this, and I want it to be this slope, but not this width. So you can put a lot of logic in here. You can even say, I want it to label this feature definition only. So conceivably, you can have a feature definition that does nothing but labeling a point or something, and that's one easy way. But you do have to annotate, but you do have to make sure it's in the template. So the cabinet has a workspace that's set up with their templates that's specifically for this annotation. But if you create your own brand new templates, you do have to follow, if you want it to annotate appropriately, you have to follow this kind of logic. Now we have a tool called the ITL remapper. So for all of those who don't want to rebuild all of your templates and you want to migrate them to the new template, the Bentley Community Sites has a migration set of utilities that can do many things, but one of them is the addition of this remapper. So this will convert your old SS2 templates, either in inRoads or GeoPack, into OpenRoads Designer. But there's a little bit of manual work. Ooh, I went a little bit fast. Did someone click? Let's see. So the way that it works is that we have our 2 spreadsheets, a CSV, one for points and one for components. And the column A will be your XIN styles in inRoads, and the destination would be your column B in your OpenRoads Designer feature definition. And so if you set those up correctly, and I've done this for the XIN, but someone should probably check it, the XIN remapper executable file, or the ITL feature mapper executable file, will ask you to choose your component CSV, your point CSV. It'll choose your template library, and it will create a brand new one with a log of what worked and what didn't work. There are some limitations to it, but thankfully it's easily overcome. So all of these videos that I'm showing you right now, they're moving at like twice the speed or something, and they're all on the Bentley website, and so we'll get to that in a minute. But we've updated this entire process of upgrading all of your design files from all the things you need to know to upgrade SS2 to ORD. And so here, my log said it doesn't like the quotation marks. I am going into the point feature map, and I replaced the quotation marks with a string. And I'm opening up the template library with a text editor. Could be Notepad, Notepad++, Ultra Edit, whatever you want. You can then just do a quick edit replace of those 3 feature definitions. Now we're going to open up OpenRoads, and we're going to look at the old template library. So if you open up the old template library just from scratch, you'll see everything is white. And you can go and update each template, each point, and each component one by one. Or in each template, there's a semi-bulk tool that says apply feature definition to points or components, and it'll list all of the ones that didn't map. If they have a different name between InRoads and OpenRoads, then it won't map. But if they have exactly the same name, then it will map. Now let's take a look at the remap tool. So this does it for all of the templates, whereas the tool that I had just showed to apply to multiple points and multiple components only work per template. One of the things that you do want to do if you're coming from InRoads SS2 is you want to go to each of your backbone points and add something called a super elevation flag. Now, this super elevation flag kind of cuts down the list of your point controls when you have to apply a super elevation point control. Or you have to go into each template and do this. And so those are one of the ways, there are a few of the ways that you can and open up your or update your template library. Now, the last thing I want to do is I want to rename the old components back to old. Another thing that's been asked is how can I import super elevation, or is there an easy way to do super elevation? If you don't have your wizard set up and your calculation set up, which is really awesome because it updates when your geometry updates. But if you have it set up right, or if you don't have it set up right, you can create a spreadsheet, which we'll show in a minute, and import all of your super elevation from that spreadsheet. So if you have to use a spreadsheet or some other way of documenting your design, there's a format that you can create or that you can use to import a CSV. The first step is you do have to create your super elevation sections and your lanes through the OpenRoads tools. But once you have those, then you can go and import your super elevation. And so here I have my InRoads report on the left and my modified report on the right in the right format. It's telling me the name of it, the station, the slope, and the right side or left side. There are many videos online on how to do this. It's in the Learn server, it's on communities, it's in the help. And so this is the link to all of those migrating videos. So what's really important is that you guys know that this exists. So I really hope you're taking a screenshot of this because it's going to go away in a second. Or you can just go to Google and you can Google migrating data to OpenRoads Designer, and it will be the first link. So this was a lot of information. I do want to make sure you guys know that these things exist. If you do have any questions about any of this stuff, about this presentation, feel free to ask in the Q&A or in the chat. Pretty open. And I think that's all I have. So I'll turn it over to Kevin.
Yeah, thanks, Alan. You hear that? Hear that, Gormley? That's production hours dropping for converting jobs. That's what I'm hearing. Then we do have this last poll here. So are there any questions we didn't get answered? We've tried to answer them as we've gone along.
Yeah, there was one that Greg asked about the.
Oh, yeah. We've seen that with Palmer too, haven't we? Yes.
I'm able to put cut fill volumes on dynamic cross sections, but it comes in as 0 on my sheets. Any suggestions? So if you haven't had the class that Sam teaches with CAD productivity, please take it. It's in the book. But you have to, once you create your cut fill volumes, you have to run the in-area volume report. And then the report is what the annotation reads from. So once you run the report, the annotation should fill in itself.
We cannot stress enough, guys. Take the classes that are offered. The books are worth their weight, honestly. We're going to refer to people, if they contact us for help, and not me, but Aaron, Patrick, Erika, if they contact them, we're going to refer to that book because it is step-by-step on what to do. And they're virtual now. You can contact Marcy Fisher at KY Training to get signed up for that. That's anybody that wants to take it. We're starting into the regular series of MicroStation and OpenRoads Designer, not the upgrade stuff. So we're going to jump into the beginner, intermediate, advanced levels and kind of go from there. So training wise, let us know what you need. We're here to help. And if we can set up some kind of custom training for you, we'll be more than happy to.
And then if you guys don't mind, if there are no other questions, would you guys mind putting down, like how are you either liking or disliking ORD, or do you have any big hangups, or are there something that's kind of like new or unique that you like if you've had some experience with it? I'd like to get some feedback to see, if there is any other additional opportunities to provide, some other forms of information, and some different ways to do the same thing.
Hey George, I was reading your question. Is there any annotations for the existing ground if the corridor model is not ran? If you just want to see what is existing, so like Erika said, you could just look at your profile if you want to put a profile across your spline for your center line. The only way that you are getting the center line, existing center line elevation, is from the template. In order to see the template, you have to run the corridor. But you can do spot checking with the elevation. There's a tool under Surface you can use for that.
And we made a video for the getting the super cross section on those existing. There's a new report that we just put out with this last CAD standards that'll get you the super elevations. If that's what you're talking about, George, I thought I sent you a link to it. I just made it, I think, earlier this week, and we'll put that on the website too. Did y'all want to go over the results of, your how familiar you are with ORD? I mean, about 40% of the viewers said that they're little to none. 28% had training but no project experience. Another 21% had some experience after training. There's only a few that have done. There's 7% that completed ORD survey or phase 1 design, and there's only 5% working on final plans. That way you know where everybody stands. And then the poll earlier, we got the final results on that too. Do you currently have an OpenRoads designer project? We didn't get very many responses, only 43 on this one. And 42% of them said that they did have a current OpenRoads designer project, and 58% said they did not. But we closed that poll at like 102, so I'm sure a lot of people weren't in there. That was only 43 people, and I think there's over 200 in here now. So, Aaron, do you see any other questions rolling in?
Sorry, I was getting text messages asking questions, but did anybody mention that there was going to be some additional survey questions emailed out on the survey about how we did that are specific to this session? Did you cover that, Patrick?
No, I did not. I thought that was going to be included in the exit poll, but they may be emailed. Is that?
Yeah, I don't know if it's the whenever those surveys are done, like how was our session, how the presenter do, there'll be a couple extra questions in there for you guys to specifically geared towards this ORD session. So really appreciate the feedback.
I don't see any more questions either, Patrick.
I got to jump into the MASH standard drawing session, so I'm out. Peace out, guys. Love y'all. Thank you.
Thanks, Kevin.
Alan, love your hair.
Thanks.
Seriously, I hate your hair.
And so, yeah, I mean, we're pretty open to any questions or comments. I think one of the things that we didn't really talk about was Ben's question, I guess, at the end. Do you guys like, what do you guys want to see with some of your survey for drainage? Do you want to see, the inverts or just simple points, or do you just like seeing it in 2D, or what do you guys typically like to request, or what would be useful?
Okay, Alan, I'm going to answer a question real quick that come in late here. John Wiley. He says, how have you dealt with ORD compatibility issues with Bentley's updates? Sometimes it's hard to get all sub-surveyors and designers on the same version. So we have expressed this to Bentley about how there's issues between versions, especially when there's a schema change. And the last we were informed...
and I'll throw in that if anyone has any questions about ORD survey, you can reach out to me directly. There's only 2 Ben Shinaberys in the nation, and I'm the one that is a land surveyor. So you can find me in either direct message or give me a call. We can talk through what we found.
Okay. So as far as the versions go, we had a talk with Derek at the very beginning of the year, Derek Gray, and he has told us that from now on, for this year, we will stay in the same schema change. So you will only get one schema change a year. So even though we may have 3 or 4 versions throughout that year, any work or any files done within that year should be good for that version. Now, when it becomes a new year in 2021 and we get a new schema change, it'll be a little bit more difficult. But we'll just have to stay on top of it and make sure that your subs and your surveyors are at least staying within the same schema changes you are.
So yeah, there are good practices to add on that. But in addition to that, which can be helpful, it may not be the answer to all things. But in the next version, it was, I think, released or announced today on one of the calls that the next version, I think 10.9, will have the ability to, it's a technical preview, to downgrade your schema. So if you are in 10.9 and let's say all of your subs are in 10.7 and they need another couple weeks but need to keep working on it, you need to buy them some time, you can downgrade a couple of your files or your entire folder or a single file into that matching schema change for them to be able to confidently utilize. But again, also too, it's one of those things where you definitely want to keep, as a best practice, keep in the same schema, but you can still reference other files as long as you're not changing anything, right? So if you're in a newer version, you can upgrade a file and unlock somebody out of it. But if you're an older version or if you're in a newer version, you can still reference the different versions.
All right, so Patrick says it's time to wrap up. He is our host. He has to go host another session. So thank you all for coming. Thanks for all the questions. If you need anything, just email us. And thank you.